Hey guys, we're going to focus on sampling in today's lecture. Sampling is part of research, and if you get it right, uh, your project's on the way to many insightful returns. But if you don't, it probably will be questioned and doubted, maybe even discarded. You want to get the right, you have to think of a population that's interested to you. And I had the experience of doing a television advertising study a few years ago. We were going from different countries to gauge the response of respondents to a Volkswagen television ad. And we began in the US and we went to Mexico, then we went to Turkey. So we're going to compare responses. In the US and Mexico, their requirement or the target population were drivers in the US. So we wanted those in the study to be interested in buying a car. They would pay attention to us. So having a driver's license was our requirement for the US and Mexico populations. We went to Turkey, it was the same. But when we got the results back, I looked at the respondents for gender, and in 200 respondents from Turkey, there were only two women drivers in the study. And so I contacted our data collector in Turkey, and he explained that that was the current percentage of women drivers in Turkey. Now, things have changed, and so women are driving more frequently in Turkey now, but that was the way it was back in the day. It was surprising, but I think you can see that the sampling frame, the population in one country, it changed when we went to another country, and we wanted to have women in the study as well over there. So a sampling frame is this list of eligible sampling units. And the units might be businesses, they might be customers, they might be taxpayers, might be club members, but that's your is going to be your sampling frame. And so here we can see in this illustration that we wanted to have single parent households in Chicago. We had a list in yellow supplied by a vendor, and that overlap area is the accurate group that we would result with. But if we had anybody in the outside of that green sector, it's going to be sampling frame error. It's not the people that we want. Now, the central limits theory is a powerful theory in statistics. And what it proposes, and it is a powerful one, so there's it's almost law-like here, but that despite the underlying distribution of respondents in your population, when you draw repeated samples from that population and you compute the mean for each sample, and then you develop a sampling distribution, which is a distribution of all your sample means, you find that the sampling distribution that results has a symmetrical form. And if you take larger sample sizes, that bell-shaped curve is going to be tighter and closer to the mean value there. So you get more precision with larger samples. And so your estimates of the mean are closer to the population mean when you're developing this sampling distribution. So the impact force here in sampling is that larger samples help us, okay? And so larger samples reduce this sampling error, which can result from this just randomness that could occur just in pulling people out of the population. But then there's non-sampling error. So this is the more factors here. And in other words, was the survey done correctly? Was the sampling, were the questions actually the ones that you needed to ask? Were respondents actually alert and ready and able to record their responses? So there's a story that goes back to 1936. Literary Digest was a magazine. So it had a subscription that was nationwide. And so the editors wanted to predict the outcome of the next election in the United States. So Alf Landon was running against Franklin Delano Roosevelt. FDR was running for a second term. So they did a sample here using the subscription list for Literary Digest. They had a huge sample. Final sample was 2.3 million, but it predicted that Landon would win the election. But then the actual election was that FDR won almost by 2-1. So how did these results happen? Well, basically, the more affluent people in the U.S. were the ones that were in the sample frame. Those were the ones that could have subscribed to a magazine in the Great Depression. And so it ignored all the vast number of poorer citizens in the U.S. So there was a bias there and it resulted in great embarrassment. Not surprisingly, Literary Digest as a magazine went out of print not long after that. So we have sampling error. And so here, if you have small samples, this can get you in trouble. So get bigger samples, get a more diverse sample. Then you have non-sampling error. So these are these factors that are just sloppy questioning, sloppy answering by respondents, coding errors that would occur after the surveys were taken, the entry was done badly, analysis was done poorly. So, and then you have these non-response errors. Those who respond are different than those who don't. So non-sampling really is the big killer here. So on average, it accounts for 95% of survey error. So it's the design of the study and the application of it, the implementation of it, that winds up being the killer or leads you to wrong results, more so than sampling error. Sampling error is just really from randomness that might occur in your results for your study. So we see we got random sampling error and then non-sampling error. So we have a response error, then non-response error. Then we have the research error, interview error, respondent error here, and then all these ways that the researcher can make mistakes, the interviewer can make mistakes, the respondents can make mistakes just from being unable to respond correctly or unwilling to. So the sampling process begins with defining the population, determining that list or that sampling frame, and then selecting sampling techniques, determining the sample size, and then executing the sampling process. So probability sampling, and this is requires great thought, great effort, and cost to do probability sampling. Then we have non-probability sampling, which is done most frequently in marketing research studies. There's more error brought in here with non-probability sampling, but I guess the accessibility to doing it and also the more reasonable cost to do it make it relevant to marketing researchers. So here you have non-probability sampling techniques at the top, and then you have probability sampling techniques at the bottom. At the top, the one that you want to focus on is quota sampling. So quota sampling here is maybe you're concerned about ethnic identity in your study. You want to make sure that all ethnic groups are proportionally represented in your study. And so to do that, you would, let's say that African Americans have 12% of the population in the US. So you want to make sure that 12% of your final sample has African Americans in it. And so you would essentially target these segments and then fill these segments until you got 12%. And so then you would go on to the more easy to get segments in your study. Convenient sampling is just grabbing whoever is convenient. And of course, that results in dubious results many times. Judgmental sampling, sometimes the researcher knows who would be representative of the population, but that still is hard to defend later on. Snowball sampling, if you have difficult or elusive populations, and it might be, for example, those who have immigrated to the US without proper authority to do that, they don't want to acknowledge who they are. So you might find one who will talk to you, and then they would refer you to somebody else, and they'd make an introduction. So you go on like that to get the difficult or elusive population. In probability sampling, simple random sampling is the gold standard, but again, it's requires a lot of effort, a lot of planning, and a lot of expense to do. And so probably you're going to bounce back to the non-probability sampling techniques like quota sampling and address your segments of concern. There's also systematic sampling, stratified sampling, and cluster sampling. We'll take a look at those here shortly. So probability sampling relies on the selection by chance, but it is costly to do this. The different types of non-probability sampling we've talked about already. In quota sampling, you'd have this stage one where you'd identify a control category, and it might be ethnicity, and then you'd fill those difficult to obtain categories with the right numbers, and then you go on to your easier to fill segments. For simple random sampling, it's extremely expensive to have everybody in the population have an equal chance to entering your study. Stratified random sampling, here it's same as quota sampling, but in stage two, there's a probabilistic selection. So you would, by probability, select from a group of African Americans to come into your study. And so that's the stratified sampling. Systematic sampling might have a defined target population, might be customer list. And so what you're going to do is, have once you identify, the different types of customers, you'll have they'll be brought in a proportional way into your study by a random selection process. And then cluster sampling, you might have phone exchanges or areas of the city. So in single stage, you'd sample the blocks, and then you'd have an exhaustive census of everybody on that block or in those blocks. And then the two stage, you'd select randomly a group of blocks, and then you'd have a sample of units on those blocks. So that's the two-stage cluster sampling. So the simple random sampling, here you can see it's creating a sample frame, assigning numbers, and then having everybody randomly chosen to enter the sample, and then going out and collecting the sample. There are also internet validity threats now that we are doing online studies. So if everybody's just volunteering for your study, that can lead to biased samples like the Literary Digest poll. And so that winds up to be a convenient sample, and that's not what you want to carry forward in your research. Can be time zone biases. So if you open up the study on the internet at 6 p.m. In the Eastern time zone, it might fill before you might get 1,000 respondents if you let it go to that in the Eastern time zone and none for everybody else. So you'd have to shut things off once you get a proper amount in the Eastern time zone and move to the Central, get a proper amount, Mountain, Pacific, Alaska, Hawaii. Okay, so when we move on to sample size determination, we're using statistics to do this. So it really is driven by this precision level for studies. And so we're usually almost always using the 95% confidence level. And so here we've got 200 people with a probability of the right group being encountered 45% of the time. And then we'd have an error rate of 7%. But to reduce that to 3.5% plus or minus for our probability for our targeted group, we'd have to have a sample size of 800, so 4 times the amount to reduce that error to cut it in half. So here is basically the sample, the distribution that we use in statistics. And so here we have, a bell-shaped curve. The area in blue on the left and the right accounts for like 2.5% on the left, 2.5% on the right. So if you sum those two, that's 5%. So that white part underneath the curve in the center part of the frame here, that represents 95% of the distribution. So the original units, we can see the mean value is 50, but what we're doing here in moving to statistics is we're transforming these real values like 50 and then into a new scale, the Z scale. And so we do that by subtracting each respondent's value from the mean value and then dividing that by the standard deviation. And so then we get the Z values here. So we get a Z of 0 in the middle. It's always 0 in the middle. Then we get a Z value of 1.96 that corresponds on the right to the area that marks off 2.5% on the right of the curve. And then on the left of the curve, we have minus 1.96 marks off an area of 2.5% there. And so this Z value of 1.96 minus or plus, that is a figure to burn into your mind here. Okay, so it keeps coming up over and over when we're using a two-tailed test. So here we have an example of the New York Times poll. This desired level of precision is the sample value, p, minus the population value, pi. And then the n for the computing the number in the sample, we have pi times 1 minus pi times z squared divided by d squared, which was that p minus pi squared. So the greatest variation occurs when you have two groups that are almost equal. So here you have two groups, one value of 0.5 and the other value of 0.5. And then at the 95 confidence level, the Z value we're looking at is 1.96. And so the Times poll reported that their level of precision was 3%. So how big was the sample? So we can plug in the numbers here and determine our answer here. We can also go out on the internet and use a calculator here and plug in these values. So here we're at calculator.net, and values here that we're looking for in our New York Times test poll here. We have the margin of error is reported as 3%, and the population proportion, we'll leave it at 50% because that is the kind of the worst case scenario. It's the greatest variance there. Okay, and then we punch here to get the population size. It comes back as 1,068. So this corresponds to what happens for countrywide media polls. They are usually 1,000 in number. And so that is what occurred here in the New York Times poll. ABC News polls, NBC News polls, Fox News polls, CNN News polls for the nation, and they're 1,000 people. So basically, there's not a significant gain in precision to go above that. Okay, so let's go back to our there's another study. This was done nationally here with TNS InterSearch. So we went out on the internet and actually repeatedly sampled over a period of 2 waves, 30 waves, 2 years, 30 waves with a population value of 0.60 probability of taking an out-of-town vacation in the last year. So again, if we use Z equals 1.96, 30 waves of 1,000 each, how precise is this prediction or estimate of 0.60? So we can go out to calculator.net again. All right, so here, let's put the population size here. Okay, sample size we'll put at 30,000. and population proportion is 60%. We'll calculate that. So the margin of error here is 1.75. Okay, so what that means is that our estimate of 0.60 probability for people randomly being chosen, that we'd have 60% chance of finding somebody that took an out-of-town vacation last year, and that's accurate, plus or minus 1.75. All right, so completion rates. We had a study here in Wyoming for the budget. We actually had 400 usable responses in our study, but we began with 437. So that was our initial sample size. So here we can see the completion rate here in that study was 91.5%. I think that's a very healthy figure, above 90% here. So this is eliminating people who took it too fast, didn't really apply themselves. And so we've got an estimate of I guess, how willing people were to be able to take the study and handle it. So improving response rates, you can give people prior notification that you're going to engage them and recruit them to do the study. This can be done through mail, email, even text messages these days. You can motivate the respondents by a foot in the door technique, basically asking something small, like, something like, do you have the time? And then could I also ask you about these questions I have? And so that's the foot in the door. The door in the face would be asking somebody, I have a study here and it's going to take an hour and a half to do. And people say, oh, I don't want to do that. Oh, I have another one here. It'll take 10 minutes. Okay, I can do that. So that's door in the face technique. Incentive respondents always do that. Their time is valuable, and they'll work with you if you do that right. Keep the questionnaire short, and then do a good follow-up, maybe sending the entire survey out if it was a mail survey to everybody again, or at least those that didn't respond. Adjusting for non-response here. At the end of your study, you look at your results, you might find that you had within one group, it might be Asian Americans, the proper proportion, you're under on those. So that only 85% of the group size that you had hoped for actually came in with Asian Americans. So in a post hoc or after the event way you can do this is to add a weight to every Asian respondent's answers. And so so here we have 100 divided by 0.85. So that would get a weight here of about 1.15. So that's a way that every respondent would have their answer multiplied by that weighting figure. Now, I personally don't prefer to weight, because we should have done a good job in our sampling and executing the survey, but also later when we're using statistical techniques like linear regression, the assumption for running the model is that everyone gets a weight of 1. So you'd have to go back to your unweighted sample to run the results for that. So that can be confusing, or you need to stay on track on that. There's also imputation for studies that might have to do with electrical utilities who are trying to estimate what the metering or electricity activity would be in a new neighborhood for people that are coming in. They might impute the values of those in similar neighborhoods for actually occupying those homes and drawing electricity that they did. And so you could impute, a sample from that, from the respondents you don't have, and come up with some estimate of what percentage of ethnic groups or comprise that new neighborhood, education levels, that. So As you can imagine, there's subjectivity there. However, sometimes if you're using, you know, a lot of prior data that gives you some precision to make these imputations, you could do that. I've never done that in a marketing research study, though. That would probably be done for something the government would do with regards to composition of neighborhoods or that they currently don't have information about. They're making an estimate. Okay, so here's an example for statistically adjusting the data. Okay, here you got the age group is 15 to 24, but here you have these three subgroups of this age group, and one of them is supposed to be 30%, and that's what you got here. So you can see this 30 and 30. So the sample is 30. In the red group, you're supposed to have 40%, but you had 36. So here you weight each red group person with 1.11. And then for your green weight, it comes in a bit over. So you divide 30 by 34. And so every green group member would get a reduction of weight of 0.88. Okay. Thank you for your attention today. We look forward to continuing on in our class here as we move into designing questionnaires.